Diagram shows a vertical square coil whose plane is at right angles to a horizontal uniform magnetic field B. A current I flows through the coil which can rotate about its vertical axis OO'. Which one of the following statements is correct? We've got the force on two sides of the vertical sides of the coil are equal and opposite. A couple acts on the coil. No forces act on the horizontal sides of the coil. If the coil is turned through a small angle about OO, it will remain in position. Okay, now, if I look at this, what's going to happen is people get confused. And they get confused because of the diagram of what's actually going on. They're so used to looking at an armature, the coil of wire in the middle of a motor, where two sides of the wire are perpendicular to the magnetic field and experience a force, and two sides are parallel to the magnetic field and experience a force. Now I'm going to redraw this. So if we jump across, and I'm going to draw it, whoops, jump across, let's try again, there we go, and I'm going to draw it. So what we've actually got then is we've got a magnetic field coming out of the page, and I'm using the dot and cross notation. So the dot, if you remember back to your dart, means it's coming out of the page towards you. You see the dot. The cross is going into the page. You see the back of the flights of the dart. And what we have is a wire that's in a coil or in a square that's actually running through that perpendicular to the magnetic field. So it's actually in the plane of the paper. They've shown us on this side the current is going up, and this side the current is going down. They've actually said as well what we have is a point about which it can rotate. So we've got that's OO'. Now you can see that all four parts of this wire, the current is running perpendicular to the magnetic field, because the magnetic field's coming out of the page, the current is running in the plane of the paper. So what that means is each of the wires are going to be experiencing a force. So I can't quite, I'd put it in the middle if I could, but there we're going to have a force. If I use Fleming's left-hand rule, let's check actually. FB coming out of the page, current going down. That means I'm actually going to get, oops. So I've got magnetic field coming up there, current running down. Therefore, I've got a force running in that direction. So my force goes in that direction. Opposite direction, same magnetic field. Opposite direction current means the force over here will be going in that direction. On the top, we've got FB coming out of the page. Current's going to be running at top. Therefore, my force, rewind again, my current's going to be running that way. So what I've got then is FBI coming out of the page, current running across. Therefore, I've got a force here going down. And the bottom one will there be current running in that direction, FB coming out the page, current running that way, current running up. So you can see I've got all four forces acting on each of those wires. So if we go back, which is the correct statement? We've got A, the forces on two vertical sides of the coil are equal and opposite. Well, actually, that's yes. In fact, the vertical sides of the coil and the horizontal sides of the coil have got equal and opposite forces acting on them. B, a couple acts on the coil. No, because there's no turning force actually being applied, because these are going horizontal. So B is no. C, no forces act on the horizontal sides of the coil. Well, that's no, because there are actually forces acting on the horizontal sides of the coil. Because they're perpendicular to the magnetic field. And D, if the coil is turned through a small angle about OO, it will remain in position. Well, no, it wouldn't, because the forces are going to be slightly unequal, and it will actually probably pull itself back. So D, the answer there is going to be no. So therefore my answer to this question is A. Thank you very much.